Welcome back. This is for Lab 1, the retirement calculation. This was the input variables. What I asked was if you wanted to set up your retirement. In other words, when I retire, let's say we're going to hopefully live another 20 years after retirement. If I want to make sure I have enough income to survive for those 20 years, how do I figure out how much do I have to save each month that I'm working? That was like the basis of the lab. And what I said was in this example, and I gave you numbers at work, but you can use your numbers. Like obviously, you're going to work more than 23 years. This was my example. Um, so I plan on living for 20 years after retirement. My annual return for retirement is around 2% or so. If I used a benchmark income of $10,000 a month, and assuming Social Security of 2642, that means I need about 7458 or so in income per month. So how do I get that? Well, I need to figure out what the cumulative amount of the money is going to be with this calculation. In other words, with 20 years of income, with 2% per month, and a payment of 7458. So um, that's an accounting formula. Okay, there's a couple of ones that you want to sort of keep on the back burner. Um, it's not really an accounting lesson; it's more like a life lesson. These are ones you want to understand how they work. The first one I'm looking at is a PV calculation, present value. What this number is, this number here, $1.454 million. This is 20 years of 7458 getting 2% per year in interest will equal up to that present value. If you look at the inputs, it's B8 divided by 12, B7 times 12, B9 minus B10, and 0 for compounding. So in other words, if I took that lump sum of money and split it out over 20 years, getting 2% per year, I'll get that payment out of it. Well, now I look at what I have to save each month to make that pile of money, to make with that $1.45 million. At 23 years and a 9% average annual return, that is a PMT calculation. PMT. PMT is sort of like a PV calculation. The formula is a bit different though. And I can show you what the formula looks like with powers and all that, but this is what the formula looks like. PMT uses the rate, uses the present value or the money, or excuse me, not the present value, the future value. Assuming that I'm not going to start out with any any starting funds. In other words, I'm not going to start off with like $10,000 and add to that every month. So how do you figure out the formula for present value and the formula for payment? Well, the two standard formulas, like I said, if I go out to Google and I said Java, or let's say PMT formula. Let's see. What is the actual formula behind the PMT in Excel? And well, I want to see the math formula. I don't want to see the Excel formula. How about there we go. Some guy from CISC181 put it out there. Sometime. There we go. Simple interest, compound interest. Here's FV equals PMT. Here's PMT FV. Here's a PV calculation. Here's a PMT calculation. Well, the one thing I said at the beginning of the class was that there's the best way I can say it is there's nothing new under the sun. Whatever you're going to do has been done before. PMT and PV are common calculations. If I look for Java PMT function, I'm sure somebody has done this already. And let's see. Here's the PMT function in Java. I'll make this a bit bigger so we can read it. Return 1 minus payment times loan number. What I'm looking for, I know that it has to deal with a math_pal function. In other words, I know that you have to raise the power of to get to compounding. But let me tell you how programmers really do it. Something like this, I would expect to see already packaged in an API or packaged in a class that I could use. Finance Lab is a class, and I stumbled on this pretty quick. It's a class called org.apache.py SS formula functions. Apache is the place that does application web servers. So I know this is probably a bulletproof class, if you will. This class, this Finance Lab class, has future value, present value, net present value, payment, pretty much everything I need. And they're methods that are exposed that I could reuse. In other words, I don't have to, if I want to, I don't have to write the calculations manually. If I look hard enough, I could probably find the source code for this. Let's say if I looked for Finance Lab source code. I'm looking around. I'm cutting and pasting the real class. Yep, this is it. So here is Finance Lab. This is future value. This is the actual Java class or Java implementation for that. I'm going to make my screen a little bigger so you can see. Here's future value. Here's present value. Here's net present value. There's payment. Let's make it a little bit simpler. Let's look for a downloadable jar for this. I mean, why copy the implementation again? There we go. Download POI 3.8 beta. Okay. So within this jar file are just a ton of classes, and the one that I'm looking for is the Finance Lab class. So I'm gonna search for Finance Lab. Yep. That guy right there, org.apache POI SS formula functions Finance Lab class. This jar file that's published in Java, that file right there, that jar, has exactly what I need. So I don't have to hold you hostage while I'm building a project. I built one already. What I did was I created the project, and I already downloaded that jar file. And all I did was I went into Properties, I went into the build path, I went to Libraries, and I added an external jar, just the file that I downloaded, and this was the external jar. So that jar is loaded under Reference Libraries. Remember all the classes that were in this, like all those classes? All those classes are right there. And this is me calling or importing org.apache.py.ss.formulas.functions.finance_lab. Imported that class, and I can't make it bigger, but from here I can use the present value and use the payment calculation. I could have either done this or copied and pasted the source code that was part of this, but this to me was a little bit easier. Let's take a look at what my printouts are. Now, the variables that I have, now you got a little bit more work than this. You got the scanners where you're going to input the variables, but I just use these as hard coded. I had hard coded 23, 9%, 22%, and 7458. Let's take a look at what I hard coded. I said, first thing I have to do is figure out the present value. I have to figure out this part first. And I said that I was 2% divided by 12. Number of payments was 20 times 12. 20 times 12. The Y, or the payment, is 10,000 minus 2642. The future value, in other words, the money that's left over after the payments are all paid out, is 0. I don't want any money left over, 0. And with these variables, I can call that present value calculation, our method, and get the present value, and it should be equal to what that is. The next part is the 9% over 12 months, 23 years at 12 payments per year. Present value of 0, future value of whatever I figured out from present value, and compounding at the beginning of the period, and my payment. So let's take a look at what my outputs are. My present value output was 1.454485. Perfect. My future value was 1589. Perfect. I could have used now all I have to do now is add my scanners, and when I add my scanners, this is going to be a variable, that's going to be a variable, this is going to be a variable, that's going to be a variable, that's going to be a variable, everything else is the same. Present value, payment. Thank you very much.